At the beginning of everything there was an unimaginably beautiful fireworks. The theory is that the universe has expanded since the massive explosion of about 13.79 billion years ago. To explain in more detail the theory that the universe is now expanding, assuming that if you go back to the past, everything would have been in one spot and then expanding from that point to the present universe. While it is true that the Big Bang has occurred, the hypothesis that the Big Bang gave birth to the present universe continues to be discussed. While the rapid expansion in singularity itself is beyond dispute, the theory that even before the Big Bang, the universe and matter existed, and that matter only extended into the Big Bang is being studied. Even assuming that matter existed before the Big Bang, it is a possible story because it does not go against the observational evidence found so far. This is also one possibility of the pre-Big Bang status that needs to be identified in the Big Bang theory. In 1927, a physicist and priest named Georges Lemaitre, who taught at the Catholic University of Belgium, first argued, which developed into the current Big Bang theory. Although Lemaitre was a priest, he persuaded the Pope that cosmology as a science has nothing to do with creation as a faith. Scientists, of course, are human, so they can't be completely affected, so there was a backlash. So, of course, it wasn't accepted from the beginning, and the theory of normal universes, which opposed the Big Bang theory, was once in conflict. Big Bang theory sounds plausible in the original language, meaning great explosion theory when it comes to solving its meaning, and was called primitive fireball in the early days. The word Big Bang was first used by physicist Fred Hoyle, who supported the theory of normal space, on a radio talk show, saying, "Expansion cosmology is like a stripper popping out of a giant birthday cake, bang, dot." And when Fred Hoyle appeared on a radio program, the word Big Bang came out a little bit. Such as the integration of quantum mechanics and relativity theory, the theories explaining the causes of the Big Bang and the beginning of the Big Bang after the start of the Big Bang have not yet been completed, so it cannot be fully explained. Also, since the observable space background is so far an observable universe, it is impossible to identify the events and phenomena that are taking place in the invisible universe. The unexplained part is the moment of an instant called Planck time. According to the theory of quantum mechanics, time below is not observable, it is impossible. What was there before the Big Bang, or what happened 5 minutes before the Big Bang, is something scientists still can't explain. The theory of relativity states that time and space form a single structure that combines the two, and that such a structure is influenced by the laws of physics, so without space, there is no time to explain. It is not true that the term time has come into being at the moment of the Big Bang, so questions are not formed from the beginning. To be exact, the error is due to the obsession of normal cosmology, which is interpreted by the accepted Newtonian mechanics of common sense, that this explanation in itself flows steadily. That's why no scholar would answer unknown to the condition before the Big Bang. There is no north than the North Pole, Hawking said. It is not this theory, but it explains the singularity, but because the moment of the Big Bang is also a great singularity, this analogy can also be very appropriate. And the evidence supporting the Big Bang theory is that it's not a big deal. First of all, space background radiation. The greatest evidence of the Big Bang theory. Space background radiation tells us that in the past the temperature of the universe was hot enough to reach thousands of degrees, and the distribution of matter was also very uniform, without galaxies or stars forming. Second, the galaxies that are being created, including quasar, that are observed early in the universe. Quasars were the most active when the universe was about a third the size of today, and as they come in recent years, their discovery gradually decreases. This suggests that the environment of the universe after the Big Bang in the past was different from the present, which was relatively time-consuming. Third, the mass ratio of hydrogen and helium in the universe. The mass ratio of hydrogen and helium found in most stars and gases present in the universe now stands at 3:1, which is consistent with the ratio of elements produced by fusion in the universe that was cooling at the time of the Big Bang. The number of protons present in the universe now stands about 7 times that of neutrons, as the universe's beta decay into protons with low binding energy as it cools down, predominates against reverse beta decay. The amount of neutrons and helium produced by star fusion is very small compared to the Big Bang fusion. Fourthly, redshift observed in most galaxies. It is easy to infer that galaxies have been in one place in the past from observational evidence that the universe is uniformly expanding. Finally, Entropies Law. Unless you deny Entropies laws, there must be a limit to the life of the universe. The existence of an end in the universe means that there must be a beginning. The universe remains what it is because there used to be the beginning of the universe where it had a minimum entropy at some point in the past. And there are too many uncertainties to know the beginning of the universe just by the concept of the Big Bang, and there are countless secondary hypotheses. As attempts to explain the causes of the Big Bang itself continue, this is a difficult problem with so many theories. The typical ones are: first, the theory of inflation. Right after the Big Bang, the universe expanded frantically beyond the speed of light. Secondly, vibrational space hypothesis. Birth and destruction repeat indefinitely. Third, bubble space hypothesis. Soon after the Big Bang, a quantum bubble occurred, creating a new Big Bang, creating numerous child universes. Fourth, Big Split. A collision between two universes created our universe. Finally, pre-Big Bang theory. The matter of the universe that existed before the present universe was driven by gravity into a black hole, which caused the Big Bang by shrinking it to the point of reaching the length of the Planck. And the theory of inflation is that the universe expanded rapidly in the early days of the universe in addition to the theory of the Big Bang, which has been argued since the 1980s. The sweeping expansion of the universe that was said to have taken place during the Big Bang era in Korean, it is called surplus. The volume expanded at least 1078 times and was said to have taken place in a short time. The background of the emergence of inflationary theory is related to the theory of unification developed in the 70s. According to the theory of unification, there should have been countless magnetic poles in the universe. But every attempt to discover a self-deprecating play failed and people began to find the answer. In 1980, Alan Guth published an inflationary theory that could solve many of the problems in cosmology. Around that same time, Russia's Starobinsky and Japan's Sato Katsuhiko announced similar ideas independently, and then the theory of inflation developed based on the contributions and observations of various scholars. Inflationary theory solves the problem of not finding self-pollution by assuming very, very rapid expansion, and also other problems that have not been subsequently noticed. Why is the temperature of space background radiation uniform? Space background radiation has about the same temperature in either direction. The temperature of the space background radiation is only 100,000 to 1, depending on the direction. For example, if you put cold ice into a teacup with hot water, heat exchange is made around the ice, so the temperature at all points in the teacup is the same. The problem with the Big Bang theory is that the temperature of space at the 2 points farther than the 380,000 light-years of the horizon at the time of the space background radiation makes little difference. In traditional cosmology, it is impossible for the two parts of the universe to be at the same temperature. Because the speed of the exchange of energy cannot exceed the speed of light, the space at 2 points on the distance beyond the horizon is a place where information has never been diverted. The problem of the Big Bang theory, which fails to explain the thermal equilibrium between 2 points beyond the speed of light, is called horizon problem. To solve this problem, assuming the inflation theory that the universe, which was kept in thermal equilibrium in the early days of the Big Bang, was rapidly expanding, can explain the same temperature because the opposite side of the universe was originally very close together. Why is the universe flat? According to the theory of relativity, space and time can have various curvature and there is no reason why the universe should be even. Moreover, the flat universe is unstable, so even a slight curvature at the beginning of the universe's creation breaks its evenness in an instant. However, observations have shown that the universe remains very even to this day. According to the theory of inflation, it is possible to explain that inflation has diluted the ridges of the space-time that existed in the past, making the universe visible within our observation range nearly flat. The bottom line is that the universe has become so large that it almost looks flat, just as a person standing on a round Earth feels that the ground is flat. The theory of inflation is now accepted through observations on space background radiation, and Goose is considered a physicist who is expected to win the Nobel Prize. However, it is not without criticism at all. Still, many scientists claim that there is a flaw in the theory of inflation. In particular, regarding the initial conditions of rapid expansion, the existing model points out that it has a tremendous amount. Although relatively minor, there is also a theory to replace the inflationary theory, as with the CCC theory, which is also being studied continuously. It was announced on March 17, 2014 that the B-mode polarized light left in the space background radiation was observed by the BICEP2 experiment. Since B-mode polarization is predicted by the theory of inflation that it is produced by primitive gravitational waves from inflation, observations of this are indirect evidence of inflation. However, further studies have shown that the B-mode polarization observed here is not a trace of the raw gravitational wave, and the possibility of being found through more precise measurements still exists.